So in this video, let us continue to solve problems based on probability, and then we've got a problem here which reads like this. It says two players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? Well, this is a pretty simple problem, very simple problem based on the concept of complementary events. So what we have to concentrate here is, it says that the probability of Sangeeta winning the match is 0.62, right? So they're asking what is the probability of Reshma winning the match. The question can also be in this way. It's the same thing as Sangeeta not winning the match. The question is what is the probability of Reshma winning the match. It's the same thing as what is the probability of Sangeeta not winning the match. Because when Sangeeta doesn't win the match, Reshma wins the match, right? So that's the thing. So here we've got, say, the probability of an event happening is, say, Sangeeta winning the match, which is 0.62. And the probability of Reshma winning the match is the probability of event not happening, which is Sangeeta not winning the match. So that is going to be 1 minus probability of an event happening. So that is going to be 1 minus 0.62, right? So the probability of event not happening is the same as Reshma winning the match or Sangeeta not winning the match. So therefore, the probability of Reshma winning the match is 1 minus 0.62, which is 0.38. So therefore, the probability of Reshma winning the match is 0.38. Well, it's a very, very basic problem and a simple problem based on the concept of complementary events. So all that you need to know is how the complementary events work, and then you'll be easily able to solve the problem. Just a quick recap. Complementary events are nothing but, the probability or the event happening and the event not happening are complementary to each other. They complement each other. Those events are called as the complementary events. So this ends this problem. Let's quickly solve another problem. All right, so here we've got another problem, which is again not very complicated. It's about two friends. So we've got Samida and Hamida being friends, and what is the probability that both will have different birthdays and the same birthday? So say we've got 365. We are ignoring a leap year, right? So we got 365 days a year. So let's say Savita's birthday is on some day, right? Is like on one of the days. One of the days out of the 365 days, right? So now what is the probability of Hamida having a different birthday other than Savita? So if Savita has got one birthday, then the probability of Hamida having another birthday is 364. That is 365 minus 1, which is 364. So the possible outcomes, the probability of Hamida's birthday being other than Savita's birthday is 364 days out of a possible 365 days. So this is the probability. It's almost close to 1. It's almost close to 1. It's like 0.999 something. So that is the probability of Hamida's birthday not being the same as Savita's birthday. So that answers the first question. Now the next question is, what is the probability that both of them are going to have the same birthday? So that's going to be simple. If this is different, so that same birthday, the probability of both having same birthday is going to be 1 minus 364 divided by 365, which is 365 minus 364 divided by 365, which is equal to 1 by 365. Well, it's not necessarily required to solve it in this way. This is the using complementary events, so it's using that. So the thing is, if if there is an event of they're having different birthdays, then they having same birthday is not having different birthdays, right? So it's just subtracting 1 minus 364. Otherwise also, the chances of both of them having their birthdays on the same day is going to be only 1 out of 365, not more than that. If Savita has a birthday on, say, 26th September, then Hamida also should have her birthday on the 26th September, which is just one day out of the available 365 days. So this is the probability of both of them having their birthdays on the same day. So this ends this problem as well as this video. Pretty simple it was. I'll see you in the forthcoming videos with more problems based on probability.